video, we are going to discuss the law of sines, or sines law, or sines formula. Based on the law of sine, we can relate the lengths of the sides of a triangle to the sines of its angles. So basically in this triangle here, we can write sine alpha over A is equal to sine beta over B is equal to sine gamma over C. So this is the law of sines. Before we go to solve some problems, let's take a look and see how we can prove this law. So if we look here and then try to write the area of triangle ABC, we can write like this. So in any triangle, the area can be written as 1/2 of its base times its height. So I can write the area of this triangle like this. Let's say I call it S as the area of triangle ABC is equal to 1/2 times B, which is the base, times the height, which will be something like this. Let me call it h. So the value of h here, because now if I call this point h, capital H, let's say, so this h here, the length of BH basically, will be the C times sine alpha. So I'll write it here, C times sine alpha. Why? Because this triangle here is a right triangle, and then I can write the opposite side of this triangle based on this angle, which will be the C times sine alpha. I can write it from the other side too, right? So this height will be A times sine gamma. And in that case, I can write this area of the triangle, S of triangle ABC, 1/2 times the base, B times A sine gamma, A sine gamma. And if I do the same for the other side, I can write this, S triangle ABC is equal to 1/2 times A times C times sine beta. If I call this 1, equation number 2, and equation number 3, these three equations are equal. So let me write them like this. BC/2 sine alpha is equal to BA/2 sine gamma, which is equal to AC/2 sine beta, right? Now, if I multiply all the sides of this equation by, let's say, 2/ABC, let's see what we'll have. In that case, I'll have 2/ABC times BC/2 sine alpha, which is equal to 2/ABC times BA over 2 sine gamma, which will be equal to 2 over ABC times AC over 2 sine beta, right? Now here I can cancel out some parts, which will be the BC with BC, 2. Then this side will be sine alpha over A is equal to BA to 2 sine gamma over C, which is equal to, I can cancel out the AC here and 2 with 2 here, and the remaining is sine beta over B. So this is how you can prove the law of sine, which was what we had here in the beginning. So now let's take a look at some example and see how we can use this law. So imagine we have this triangle. This length is 18, this length is 20, and this angle is 30 degrees. And we are going to find the other two sides and the other two angles. So if I write the law of sines for this triangle, I can write it like this. Let me call this angle alpha, and then let me start with this. 18. Let me start with this. The sine 30 over 18 will be equal to sine alpha over 20. So if I find alpha, then easily I can find the other angle here, which I can call it beta for now, right? So now if I calculate this, it will be 18 sine alpha is equal to 20 sine 30, and then sine alpha is equal to 20 over 18 times sine 30, which if you calculate this, the answer will be 0.55. And then I can write like alpha is equal to arc sine 0.55 or sine inverse 0.55, which in this case, if you use degree on your calculator, then the answer should be 33.3 degree. So now I have the alpha as 33.3 degree. But is there any other solution here? I'll give you a few seconds to think. The answer is yes. Why? Because I can also consider alpha as 180 minus 330.30, 146 degree. Because we know that always sine alpha is equal to sine pi minus alpha. Pi is in radian, and in degree will be 180. So both of these answers are correct. So I can use the 3.3 here and then calculate the beta, or I can assume alpha as 146 and then calculate beta. So let me use both here. So if alpha is 330.30, then we know that 3 plus alpha, which now is 330 30.30 plus beta should be equal to 180, and this means that beta is 160.7. And also if alpha is equal to 146, then again we can write 30 plus 146 plus beta is equal to 180, which this means beta is equal to 4 degree. So probably if you draw the triangle with this alpha and this beta, you will have something like, let's say, this. This is a schematic drawing of that triangle, which this guy here is 30, this guy here is 33.30, and this guy here is 116.7. And if you use the same schematic drawing here, your triangle should look something like, let's say, this, which here is 30, here is alpha, which was 160, and this angle here will be 4 degrees. Yeah, so in this case we had two solutions for this triangle with this characteristic. Now let's take a look at another example here. What if now we look at this characteristic for our triangle and how many solutions we will have for this triangle? Again, we follow the same process here. So here I can write, based on the law of sines, 24 over sine 30 is equal to 20 over sine, again let's call this alpha, and this means 24 sine alpha is equal to 20 sine 30, which means sine alpha is equal to 20 over 24 sine 30, which is equal to 0.41, and then alpha is sine inverse of 0.41, which will be 24.6. So this is one solution for alpha. But now the question is that, can I also consider the second solution of alpha, which will be 180 degree minus alpha here, which is 155.37 degree. Can alpha also be this guy? The answer is no. Why no? Because if I assume alpha as 155.37, then we know that the sum of all angles in a triangle should be equal to 180, and it cannot be larger than 180. So if alpha is 155, then the sum of these angles will be larger than 180. So 155 here cannot be the solution. Therefore, we are not going to consider it. And then we only have one single triangle with this characteristic. But in the previous example, we had two types of triangles. So now take a look at another example, which is the last one here. Can we have a triangle with this characteristic? So again, here I'm going to use the law of sine. I will follow the same process here, which will be 20 over sine 30 should be equal to 45 over sine alpha. This means 20 sine alpha is equal to 45 sine 30. Sine alpha is equal to 45 over 20 sine 30, which means sine alpha is equal to 1.125. And here, if I calculate the arc sine of 1.125, if I calculate it like that, I will have an error, which is a domain error, which means there is no answer here. Because, of course, the domain of sine is between 1 and -1. So we cannot have something larger than 1 or less than -1, which here we have 1.125. So there is no solution here. And this means we cannot have a triangle with this characteristic. So there is no solution. I hope you liked the videos, and for more content, please do not forget to subscribe the channel. See you all soon, and peace.